Hi everyone, this is Robert again from the Siemens AI Lab, and this is day 2 of our AI Sustainability Hackathon. Welcome everyone out there watching, viewing us, and I'm super excited after a really nice first day. Everyone got started right off the bat. All the participants were very excited. I think the kickoff went super well yesterday, so yeah, glad to have you all back. And today we're gonna have, same as tomorrow, a quick update session with group interviews from all the different tracks to give you guys an impression on what's been going on there, what they've been working on, what their challenges have been. Quick recap here. So we're at the Siemens AI Lab streaming live from Munich. My name is Robert Lohmeier. I'm your host again today. And what is on the agenda? Well, we're now on Thursday, so this is the first of the daily team updates. Tomorrow evening, we're going to do the same thing, same time. And then Saturday is the big day when the teams will be pitching their results in front of a management jury. So that's the one you really should be tuning in for. Also, if you for some reason happen to miss the kickoff yesterday, that's no problem at all because it's going to be available as video on demand sometime this evening. And then available basically forever. So you can rewatch that at any time to get some more details on the stuff that we're going to be skipping today. Also, click or scan this QR code at the bottom to register for the final event. You're not going to need to register, but it's going to allow you to join our Slack channel, join the discussion, get some background info, and also get reminders on the streams. Now, on to the challenges. Again, like yesterday, we will be having 5 challenges to discuss. Health from GIZ, we have water with Confers, buildings with our very own Siemens Expo team, mobility with the Swiss train company SBB, and energy with Energinet. Now on to GIZ, they're the first of the bunch, managed by the team captains Valentin Kospel and Mitch Joblin, and they are doing positive deviance analysis for epidemic mitigation. Now, positive deviance is a principle, an idea that basically says that within communities, areas on the globe, there are certain individuals or groups that deal better or more effectively with challenges that they're faced, even though they are in the same constraints and have the same sort of environment. Now you can do this in a data-driven approach, and they're already doing this kind of analyses for example, in agriculture or how people deal with droughts in Africa. And of course, this is a really great tool to also handle, or look at how people deal with mitigating the coronavirus epidemic. So they've now started the pilot, and this hackathon is part of this pilot to do data-powered positive deviance analysis for COVID-19, basically in 3 steps. They've provided data that the participants are now working on. Step 1, use structural data to figure out, and predict in hindsight where COVID-19 would hit harder or less hard. Then also include in the second step time dynamic data in order to figure out what weather or mobility influences there are. And then the third step, take all of this and these machine learning models, these predictive models, and figure out in what areas we are seeing positive deviance, so that in order to look at that, we can then in the future actually see, okay, what did these people do differently? I think this is super interesting because a lot has been done with data science with regard to COVID-19, but this is a bit of a different approach, right? Because we're not just trying to do general data analysis, but much rather we're actually looking at outliers in our data, right? And then looking at more detail into, okay, what has been done differently for the positive outliers, okay? And now I would like to go on for the voices of the team and roll the interview.
Hi, everyone. Thank you very much for being here today as 2 representatives of your teams. Just as a little bit of background, we split our positive deviance group into 2 separate teams that are working on different work streams. So this are Linda and Tim, who are going to give you a quick update. I am Lena. I am a part of the GIZ Data Lab team, and I just would like to express once again how super honored and excited we are to work together with you guys and just observe what you're doing and see so much interesting stuff going on. This is really, really cool for us. So I have a couple of questions for you. And the first one I would like to ask you is, how did you get started? Like, could you maybe tell everybody a little bit about how you got the challenge structured and how your work actually is a little bit organized? Maybe Linda, you want to go first.
Yeah, sure. Hi, I'm Linda. So yesterday we started to set up the infrastructure, and that was quite a challenge because we're quite a lot of people in the team. So first of all, we got to know each other, which was quite cool because we have a lot of people from different domains. And then the GIS Lab introduced the problem to us. And yeah, first it was just about getting to know each other and the challenge. And then we actually split up the tasks into smaller subtasks. We have one structural model which we want to implement, and then we want to integrate time data as well. Especially mobility is in the focus, and we got a big data set for that. And this is the second team we have. So yeah, we split the team into 2 sub teams.
So Tim, what is your team working on?
Hi, my name is Tim, and I'm on the first team. We are creating a static model. Right now, we are evaluating the data and trying to find positive deviant in the data. And right now, we are trying to work with a neural network and with some linear regression to find those deviants.
Super interesting, super exciting. Another challenge always comes with challenges. So is there something you guys were facing that didn't go so smooth as you expected it to be?
Yeah, firstly, I would say the virtual hackathon, or the first virtual hackathon, is a hard challenge right now because some connection problems and stuff. But till now we managed it really well, I think, and everyone is helping each other out, and so the communication is not as good as it would be if we would meet in person, but it's as good as it can be, I think.
Yeah, so I would like to add that I really like the AWS infrastructure because the setup was quite easy, and all of the installations were pretty smooth. And I can just agree with Tim, the biggest obstacle probably is the communication, but you just get used to it.
All right, so noted that we have to work a little bit on our communication streams and get everybody a little bit more into interacting. But in terms of the challenge, maybe you can shortly describe at which point you're currently at, what you like, maybe your personal tasks are at the very moment, and also what your team is currently doing while you're here in this video chat.
Actually, right now in my team, we're just at the start. We are evaluating the data and trying to figure out some conclusions of the data. My personal task right now is to build the neural network and trying to find those positive deviants via the neural network. That's what I'm doing right now.
So I'm in the second track. We try to integrate time series information and also mobility data into the models. And Maha, Gungna, and Saurabh, they're amazing team members, and we're working on that track together. Saurabh already implemented the first naive baselines with Arimax models. And now we're working more on the weather data and especially the mobility data, because we have a lot of observations, and the structure is a little bit difficult to integrate because it's more graph-based. And yeah, we also noted that there are some missing data points, but the GIS Lab already gave us a new data extract, so we fixed that problem.
That's really, really cool to hear. Perfect. So what are you planning to do in the next couple of days? Is there any kind of goal you already kind of have envisioned that you want to reach, or is everything still a little bit open and you try to figure out just how things will turn out?
Right now, our team is just doing trial and error. We're trying to get the best results, but just brute force, do something. And then after that, we get together and see what we'll do the next few days. But we only look in the future for 1 or 2 hours. Then we meet each other and then we redefine the tasks.
I think the approach from Tim is quite good. We are also meeting constantly to update each other. And I think we want to focus on the mobility data because we think, yeah, it's a very good task to improve the COVID spread. And it's actually a little bit hard because it's a lot of data, and also the structure is not as classic as it would be for most of the machine learning problems.
All right, I see. So it's pretty much a really good COVID-19 challenge because you never know how things are going to evolve and what's just around the corner. So this is very interesting to hear. Thank you guys so much for giving us an update.
Thank you.
Yeah, thank you for this interview.
Yeah, you're welcome.
You're welcome. Thank you.
All right, super interesting update from the guys, the team for health and GIZ. Thanks a lot for the interview. I definitely agree. This is the most explorative track, right? You're doing a lot of just general data analytics. You don't necessarily have one optimization goal. And of course, for your track especially, I would say communication is key. So I think the explorative approach right now for the first day is working out fine. It's also really interesting to hear that, you know, virtual communication still lacks that direct interaction that we see when we do hackathons here physically. So let's see also how that turns out, what we learn from this. But I think that's a learning experience really everyone is doing right now and for the last months. And I'm also really, really glad to hear that the AWS cloud infrastructure that we set up for you guys is working well, because we put a lot of effort into that, and I really like to see that this turns out well. Next up, we have our water track with Confers, and what they're doing is, well, they want to provide clean water, right? A lot of people in the world still do not have access to clean water, and data science and machine learning can really make a difference here. They're trying to do this with hardware that we're basically all familiar with, which is cameras, right? And so the machine learning problem here is quite straightforward, right? You have images of particles in the water, and you're trying to classify whether or not these are contaminating the water, whether the water is safe to drink. The catch, however, is that by just providing a simple machine learning model in a laboratory environment, you might not really be catching all the details and really what's out there in the environment. So the extra challenge in this track is to provide a federated learning approach, which means that you do decentralized learning from multiple sources and can really sort of accumulate into your model all the data that's out there from different customers, different water providers, without violating, their privacy requirements either. Right? So this is the extra complexity in this machine learning problem. I'm super excited to see what Nikolai and Yinchong's team have been able to do so far. So give it up for their interview.
All right. Hello, everybody. I'm here with Team Grundfos, Team Water, with Nikolai from Grundfos, Yingchong, and Markus. Can you quickly introduce yourselves? Yes, Nikolai, why don't you start?
Yes, let me go first. My name is Nikolai. I'm a data scientist at Confers and track captain for this challenge here. So the challenge we are proposing from Confers is to do recognition of particles in water and try to determine if these are bacteria or not bacteria. So we can sort of determine the water quality. Yeah, and we add a little bit extra in this challenge that we want to see if we can have some kind of federated learning setup around it. So we can deal with things like privacy issue and and best use of resources and things like this.
Hi, I'm Inchun. I'm a research scientist at Siemens AG, and I'm a co-captain of this water track. And so yesterday we had already a technical walkthrough. So it seems that everybody has now a quite good understanding about the data situation. And currently we are exploring all kinds of possible models that we can use to apply on these data.
This is better, right? Sorry. Hi, I'm Marcus. I'm currently writing my master thesis at Siemens. My master thesis is actually about federated learning, so that's a pretty good fit for this topic. Today I was in a sub team where we implemented our first baseline models and actually had really good first results on the classification task.
Cool, thank you so much for the overview. Can you give me some general overview about what kind of data you have and how you're approaching this?
Yeah, so basically what we have is a sequence of images of each particle detected in water, and the task is basically to say whether this is one or the other, so bacteria or not. And what we've been and we have that for many different water samples. So what we've been focusing on today is really getting this baseline model up and running, as Marcus is mentioning, and I think the team is really doing an excellent job.
That's great to hear. Can you tell us a little bit about the vision of your project? Where do you want to go? How do you want to implement that?
I think one of the major targets that we would like to achieve by the end of the hackathon is to have different federated learning configurations. For example, we would like to have different locations where the label distributions are not that they're quite different from each other. That would simulate a situation where at some locations the water quality is really, really good, where there are close to zero bacterium, but at other locations it is the other way around. So from a machine learning point of view, this is a very technical and severe challenge, and this is what we are aiming at.
Thank you so much. What was the largest challenge of the day so far? What have you been experiencing?
So probably the biggest challenge always is understanding the data at first and figuring out how the data is set up and actually understand how it was generated and understand the labels, understand the statistics about it, how many labels do we have for each class. So I think that's always one of the biggest challenges, but I think we managed that quite good so far.
And which are the challenges that you're facing over the next days? What do you anticipate?
I think tomorrow we will, or as Yin Chong said, or Marcus also said, the goal is to finish the sort of standard centralized training model today, and then move for the federated one. But that is, I see, really unknown territory for many of us. So a lot of things can go wrong, but I think we have a great team. So we will make great progress tomorrow on this one.
Very nice. How has the experience of this virtual hackathon been so far? Any challenges? How have you been communicating? Can you tell us a little bit about that?
So we are basically using the Slack and Microsoft Teams for our communication, and also the Miro board.
So I guess it's working quite good, but it's definitely more difficult than when you're in one room. Like, it's sometimes difficult to get a hold of everyone and be at the same spot at the same time. It's easier when you're in a physical room. You see really fast who's there and who's not there. And virtual, it's sometimes difficult to have an overview.
I think people are good at making progress on their own and trying to fit their own schedule in with this. So making it work, I think that's really important.
Yeah, your team is pretty diverse, right? Like, where are the people from? Do you have an overview of that? Maybe different time zones?
I think most of us are located in Europe, and we only have one participant who is in South America. So that is a little bit challenging, but we are in very good communication with them.
Great. So what are the next steps for today and for tomorrow? You've already hinted at them, but how are you going to approach those, maybe in a little more detail?
I can maybe start. So today we hope we finish to train our base models and have a model that we want to use for the next days. We won't try to get the best performance out of it, because this is a really hard job and would take a lot of hyperparameter tuning and a lot of time. So we will just stick to one model after today, and then there's going to be the big challenge to set up this federated setting. So yeah, tomorrow going to be the whole day is going to be about figuring out the federated, the TF, also the framework, the TensorFlow federated. Nobody has worked with it so far, so this is a challenge. And then, of course, starting training on that and evaluating the performance.
Very nice. And maybe as a last question, your challenge is a water challenge. Can you give us a little more context about the sustainability impact of your challenge? Maybe Nikolai would be great to answer that.
Yes, absolutely. As I mentioned in the track video, I think it's around 800 million people who are lacking access to clean water. So this is just hugely important to be a part of making sure that water is clean and that you can verify that it's clean. So for me, it's really a noble cause and a place where technology can really do something. So I'm happy to be doing this with you guys.
And we're happy to have you with us. Perfect. I think that is enough for a first team update, and we will keep you posted.
Thank you.
Thank you.
Thank you.
All right, thanks a lot to the water team, and great update there. It definitely is quite a cool cause, and I also think that the federated learning approach is what really can make a difference in order to make this possible to actually scale this up and make this available to all these hundreds of millions of people who do not have access to clean water yet. I wish you the best of luck with handling the highly varying distribution of labels. To explain this a little more, so this might seem trivial, but actually as a machine learning problem, this is quite hard if you have a problem that shows only very little of a positive and very many of a negative label, or the other way around. So this is something that you guys have to take care of, but Yinchong, I know from the experience working with you that if anyone can handle this, it's going to be you. And another thing that is also quite distributed is actually your team, right? So super international, and of course this makes communication probably even a little more difficult. Then again, if you also think about the fact that this is even possible doing a virtual hackathon, right? I'm really sure that you wouldn't have worked together in this team setup with someone from South America and Asia. So that's also pretty cool to see that this is possible and we're reaching so many people with this. Okay, next up, moving on to our next track is our Siemens buildings track. And this is also quite an interesting challenge because this is reinforcement learning based. To give you a bit more of a background, so at the Expo in Dubai, it was supposed to be Expo 2020. It is postponed to 2021, but the concept remains the same. And there's a lot of buildings on the site, and all buildings are actually powered by Siemens technology. And they're aiming to have the most sustainable expo of all expos historically yet. And in order to do this, of course, a big impact will be optimizing the energy consumption of the buildings. So while you want to keep energy consumption low, you're always, in this sweet spot because you always have to compromise for comfort, especially in a hot location like Dubai. And there you're going to have to make some compromises. But, the challenge here is to optimize energy consumption without losing any of the comfort for people in the buildings, right? And for this, they're actually providing a simulation, right? So this is not based on actual physical data, but it's simulation based, and they're doing reinforcement learning approaches. And from what I heard of the team today, they're already quite on track to getting the first models done there. So I'm happy to hear about the updates.
All right, hello everybody. I'm here with the Team Expo, and let's hear how the progress is going. Can you give us an update on how you're doing?
I think so. The progress has been pretty good. The team has gone quite deep into the solution, and we're discussing how the problem statement can be innovated even further. And a lot of innovations have arrived, and we are currently in midst of developing the model. And if all goes well, I think so we'll have a working solution, at least a working prototype by tomorrow morning. Yeah. So that's pretty good. And everyone is actually giving a lot of their efforts for the hackathon, hacking all the way. Yeah.
Wonderful. What is your vision for the prototype?
I think so. We've divided the entire solution of the problem statement in 3 parts. So we primarily are focusing on reinforcement learning to control the appliances of the building in such a way that the energy consumption is reduced, as well as the comfort of the occupants in the building is not compromised. So we'll have a predictive model that can predict the next energy states, as well as a reinforcement learning model that can control the appliances at the same time. So we're trying to build the entire integrated solution together. So that's pretty much our vision. If anyone else like to add to this, yeah, please sure go ahead.
Any additions? No? Okay, so let's continue. So how was the experience? How was the hacking so far? How did it work out?
I think so the team can answer that better. Yeah, guys.
Yeah, I think we're working pretty well together as a team. We in the end split up into 2 separate teams that have 2 separate models that we're implementing, so that we have 2 alternatives that we in the end might be able to converge. And so the hacking has been pretty intense. We've spent a lot of time working ourselves into stuff and then talking to each other in meetings so that we in the end can get something done until tomorrow morning.
So what was the largest challenge of the day?
I think so it was pretty much discussing how we can set up the entire problem statement, start putting it into actual code format, and discussing the details of the problem statement. Yeah, so that was the major problem statements, and we had some difficulty into getting used to the simulation because it's the first time, I think so, at least for me, that we are having a reinforcement learning based problem, that too virtually and that too on cloud. So yeah, it's a tad bit difficult.
Yeah, exactly. I agree there.
Sorry, do you want to elaborate?
Yeah, no, I was just saying that I agree with him. There is this big infrastructure that you need to get to know, and you need to work online with your teams, get to know your teams, and try to optimize the time. So I mean, everything it's quite challenging overall.
But how did you overcome this? Like, how did it click?
Well, actually, I think we get along pretty well. We split the team in two sub squads, and yeah, that's it. We are giving step by step small task. Trying to achieve those small steps, and once we have something working, let's say fix it, and then continue learning about, continue learning, continue testing about the infrastructure, about the problem. So one step at a time.
Can you give me some more info about the current status of the project, some more details? What are the different working groups and how's it looking?
So we basically divided into two parts. So at one part, we're dealing with model-based reinforcement learning, and on the other part, we're dealing with an offline-based RL method. So the common linkage between both of them was designing the reward function and manipulating the action space, so that both the teams can benefit from that. And that part is almost done. So that now we're just working on generation of data for creating that model base and predictive analytics. And as soon as the code part of the reward function and the action space is done, we'll start training the offline model RL system, and we'll see how our reward and the manipulations that we have done actually worked, whether it is good or we need to improve it even further. Yeah. I think so.
Very
That
nice.
summarizes it. Yeah.
Anybody want to elaborate on that? Who's doing which part? How is that working?
So my team is working on the reward function right now, and it is quite challenging to find a proper one. So that's why it's important to test it out, and then after we test it and we are quite sure that it's a good one, then we can go then and train the model. So I think each part is very important. This one is especially crucial because the model at the end performs how you reward it, and we really need to make a good part of our work in that sense.
So which are the steps that you're taking next, and by when do you want to have finished them?
We have a preliminary version already, but we need to test it out a bit more. And after seeing how the results are from this this reward, we can further improve it, add some more complexity in it, more constraints maybe, and then we can coordinate with the other team to try to train the model.
Yeah, we're trying to build the solution as close to the realistic buildings as possible. So we are started with the baseline with a normal model with normal constraints, and as we close to building a realistic model, the constraints will increase and the complexity of the solution will also increase. So we are going one step by step.
Wonderful. Okay, now a bit more about your solution in general. What is the actual sustainability impact of your solution? Can you let us know a bit about that?
I think so. I had a quick discussion with some of the participants, and they had some really good inputs regarding the sustainability solution. So since we are working on reducing the energy consumption of the appliances, while not compromising the comfort of the occupants. So if the energy is consumed, you can say in a way, a lot of trees might also be saved, because if the energy consumption goes down, the greenhouse gas emission will go down, and the power supply will actually be increased to a lot of greater extents. It will reach to outer cities also, especially in case like countries like India or like the still developing countries where the power is not able to reach to the outer cities. So even if a small like if we can like around save energy for around 1 minute for maybe 1 hour for an entire stadium, that much energy might be able to power an entire village for a month, for a day, for a week. And actually it will be a great impact to the environment itself, reducing the emissions itself, and a lot more to be added to this thing. So the team can also contribute. Yeah. So guys, do you have any views on how further we can make the solution more sustainable?
Yeah, I guess like to go further and steps further, we could also reward using renewable energies, and there's a lot of ideas that we're currently having how we can go further and add more sustainable impacts. But in the first step, we decided, okay, we start with this really important part of saving energy, which is important for sustainability, and from that on, there's many more things that we can do and we want to do.
Exactly.
Okay, cool, awesome. I think that's enough for a first overview. Thank you so much, guys, and I hope you'll make great progress until Saturday.
Hi everyone, I'm back, and thanks a lot for the update from the Expo team buildings. Very interesting stuff. You know, the differences that come with reinforcement learning. Of course, the impact can be huge, because if you work on a simulation and you know, provide a model that adapts to different simulations, the scalability can be quite high. But of course, the challenge I can really relate to, finding the right reward function is quite a difficult task, especially for stuff that you're seeing right now, where you actually have multiple optimization targets, right? You want to save energy without giving up the comfort, you know, let alone what else you could consider, right? So that's a lot harder than just, you know, winning Atari games by getting the most points. And so that makes sense that you spent a lot of time today on trying to get that right. Now, off to our next track, which is the Swiss Federal Railways, SBB, and they are trying to get a better understanding basically of people's movements, you know, in different urban areas or rural areas, and especially the external influencing factors that come into play here, mainly the weather. So what they've done is they provide weather data for certain locations and the movement densities in that area. And with these kind of parameters, the goal is to predict movement given a certain time and a certain weather condition and a location. And what this can provide in the future is, of course, you know, just more sustainable services and adaptive mobility services to better meet the needs of people and really try to save energy and carbon emissions in that sense. So I'm really excited to hearing from the participants what's been happening today in their track.
Our update session for your track. You as the track captain, I'm really curious about your opinion on some questions, and yeah, let's dive right into it. You started hacking yesterday and with your team, and like, is there any vision for your prototype right now?
Yeah, so actually, I think the team has got some really good ideas on how they can apply really this predictive model for like a demand responsive transport allocation kind of use case. So you can imagine like maybe as like, for example, a company like SBB would like to allocate some of their autonomous driving buses in a certain area, and it's like really helpful to have like a data-driven way to come up with these decisions.
Yeah.
And they also, you know, had some potential use cases that I thought was, you know, particularly meaningful from the sustainability perspective. Like if we can kind of model what the typical transport modes are, like maybe we can also predict what are some typical emissions that might result from a planning that's been designed. So I think being able to really gauge, you know, based on your plan for the transport and how that can affect emissions, that's like really meaningful application for this predictive model.
Wow, sounds exciting so far. Like, you ask your participants how was the experience so far? How was it for them or for you?
Yeah, so luckily, I think a lot of them is having fun and they think it's a really interesting problem and also very meaningful. A lot of stimulating discussions going on. The only thing is, I think the digital aspect is definitely a larger challenge than a typical hackathon, and I'm very glad that the participants are super diligent and really despite this challenge, they're really trying hard to overcome that challenge. So yeah, I'm super happy about that.
Okay, we already talked about challenges. So the main challenge is to create a virtual team, I guess. Is there another challenge, or is that really the key challenge?
I think that's the biggest challenge so far, but I think the team's been working really well together, so we were able to navigate it.
Lucky to hear it. What is the current status of your project?
So I think the group were really good at organizing themselves. Also, they divvied up into different work streams. One more focused on the modeling aspect, and the other group is more focused on the application mockup and trying to prepare how we can actually apply the predictive model. So I think so far they're still kind of setting up the actual overall product itself, or not really a product, but a prototype. But they're on a good track. So I think the plan is more or less established, but it's more about execution now.
Okay, and what will be the major challenges you will have to overcome the next days?
So I think from the modeling perspective, we do have a lot of data from different aspects of this problem at hand, and it's not super straightforward. So I think the participants really had their hands full for working with all these different sources of data and merging it together and getting this nice kind of experiment set up for the predictive tasks. So yeah, it's not an easy challenge, but I'm happy we have a good group that's willing to step up to the plate.
Nice. And yeah, also about the project management, in your case, how did you structure your project? Was it a top down, like you said, this is your structure and do it, or was it more bottom up, like the team structured themselves in small teams or something?
Yeah, so I would say a little bit of a mixture of both, right? So I kind of view myself as more just providing an overview of there's some typical aspects that we need to address, but I also think it needs to be, motivated by them on exactly how they want to execute it. And I think we have a good group that was really motivated and able to really drive that on their own. Yeah.
Really nice. As for our participants of the stream, what is the sustainability impact of your solution? Or the future solution you will find?
Yeah, so I think they highlighted a few. One was being able to see if they can have smarter ways of allocating public transport, and being able to gauge what the emissions would be of a particular planning. I think this is one way we can help companies like SBB be able to have a better way of planning these public transportations, and also keeping in check their impact on the environment.
All right, thank you very much for this update, and I'm really curious about hearing from you tomorrow. And yeah, thanks for participating, and have a good evening.
Yeah, thanks for dropping by for the chat. Okay, ciao.
Ciao.
All right, cool. Thanks a lot to Vera and Diana for the update. I'm really glad to see that, even though it is a challenge, and these are quite large teams for a hackathon, that actually things are still working, and, with smart delegation and people really taking ownership over their own topics, things seem to really work out quite well. Another fun anecdote actually, so I of course went to greet all the teams today in their respective channels, and you know, I wanted to really get it right and make a good impression. So what I did when I entered Diana's track was actually I was really sure I had shut off my camera, but I apparently hadn't, but everybody else had, and I was wiping the camera as I went online with my shirt, so I basically greeted everyone with my belly button in full screen. So that's a fun little anecdote as well. If Diana, if you or anyone from your team took a screenshot at that moment, I absolutely deserve it to be shared on the internet for everyone to see. So yeah, well, so much for that. So that's my biggest hiccup for today, personally. Moving on to the next track though, which is EnergyNet. And EnergyNet is providing a platform called Project Origin, which is really at the center of this challenge. Now, what they're trying to do as Denmark's primary energy provider, and with the goal of being completely renewable based until 2030, is you want consumers of energy as individuals to be able to really track the origin of their energy source, not just on a daily or monthly basis, but actually on an hourly basis. Right? And this will make a huge difference, and is also actually in line with the requirements of the EU for sustainable development. This will make a huge difference in actually enabling consumers and empowering consumers in order to make their own decisions and buying green electricity. But to do this right, you really have to smartly match the production of energy to the demand of energy, which is already quite a big challenge in and of itself. But if you want to do it on an hourly basis, it really gets quite tricky. And this is where AI comes into play. So you're trying to predict the energy output of energy producing assets for the future, and we are doing this for wind turbines, so mainly this is going to be weather based, and I'm really excited to see what Mikkel and Florian's team have been able to do so far. So give it up for their interview.
Yeah, thank you, Robert, for this kind introduction. So I'm here with the team of the Energy Track, and we will just do some track update and a short conversation of how your project has been progressing. So how are you guys? How are you feeling? How is this hackathon so far? Maybe
nice. I'm doing great. I think the team is doing great. I think everybody, I mean, apart from too much data wrangling, had a lot of fun until now. Yeah. We had like I would agree.
Cool. Yeah. So maybe what was the largest challenge for you guys today, and how is your project moving forward?
I think the biggest challenge was maybe at first the communication, and then deciding on who works in which team and works on what task. And then, also like deciding how to arrange the data and how it has to be wrangled to get it in the shape we want it to be.
Mm-hmm. So you talked about this data wrangling. So what did it include? So what were the steps you had to take in this process?
Yeah, there were like several steps. For instance, we had data like turbine data where we didn't have location information. Of course, we had to remove these data points since we want to combine this with the weather information. So we need the location of the turbines. This is something we didn't expect, and there was also something funny where the location information actually changed of turbines over time. We also had to deal with that. Yeah.
Okay. And how does one cope with these challenges, or how does one merge the different data inputs? Is there any strategy you're doing?
Yeah, so the main strategy is, of course, to merge them by the date index. But we also have to be careful not to just push all the data into one big table, because it gets too big to handle, and it's not very, not a good idea.
Okay. Yeah. So but how far have you come with this data wrangling?
So yeah, we are probably gonna be finished with it soon. So we actually hope that this evening we'll be finished with the data preparing phase, and we can really go to the modeling, and maybe even have a baseline model which we can compare our actual models later on with that we can already implement at least this part today, or at least tomorrow morning. and then move on to the real modeling steps.
Cool. And so maybe you can elaborate a little bit more on why somebody is actually building a baseline model. Why is it important to have one? Or is it usual in the development process to have baseline?
Yeah, it's a standard. Like it's a really kind of the easiest model that you could come up with. And of course, you want your model to be significantly better than, like, for instance, a naive prediction model. And this kind of the baselines, there are several ways you can compare it to straightforward versions. For instance, in a prediction task, you could just do a naive guess by taking the last data point as your prediction for the future, because it's quite simple and stupid, so to speak. But you want your own model to be much better than that.
Okay, I see. So it's like validating the output you get, basically.
Yeah, validating how well your predictions actually work.
Cool.
Thank you. Easier guesses.
Yeah, thank you for this explanation. I think that's really interesting. So maybe, so we talked about what you're doing next. So you want to build the baseline model, but how did you actually come so far? How did you structure your project?
Yeah, so far we've been looking at the data and the different data types. So, for example, we have a lot of weather data for the wind turbines. Then we have the sort of master data, which describes basically what all the data is. Like, has the location data, for example, for the different turbines, which is going to be needed to actually make any predictions. So the weather, so we have basically one weather team. Then we have like one team for the master data, and then we have one team 3, which is kind of looking at the actual outputs and also yeah, some kind of a business aspect.
Cool.
Of the whole project.
Yeah, nice. Thanks. And maybe like to wrap it up already. So how is the experience with this virtual setup? I think one of you already did a hackathon, if I remember correctly. So how does it compare? How can it hold up in this time?
Yeah, so I've been lucky enough to be able to join the hackathon in Munich last year. And I think the only thing I'm missing at the moment is the food. So, but I can manage at home as well. But that's definitely one interesting part. And obviously, like all those small conversations you have like in between when you get coffee. Yeah, also free coffee was also cool. Yeah, but apart from this, like communication is definitely difficult in the beginning, but I think you can get used to it.
Yeah. So also the virtual setup, is it kind of stable now? Everybody gets into the right calls?
Yeah, I would say so. Yeah.
Okay.
I mean, one good thing is about this setup. I think last year we had like 10 people in the same room, and now we have like those virtual rooms. So these are easier to distinguish between, and so there's also some sort of privacy that you don't have like in those meeting rooms. So like everybody, so when like 3 teams are trying to talk, it's easier like if it's like in a virtual room than in the actual room. So
yeah, sure.
Yeah, but I think it's also a bit harder if you just want to brainstorm something. You cannot just go to a blackboard or whiteboard or anything.
Yeah.
And just visualize what you're thinking. It's a bit more complicated online. Of course, you have similar tools, so you can still do it.
Yeah, I think it depends. Like maybe there are also some people who have like due to the pandemic have some more experience now with working from home, but
true.
That's not the case with me. So
yeah, and sure, and you don't have to wear pants, right?
But
I have to.
That's true, Dominic. We really appreciate that. Yeah,
I'm
so
sitting at AI Lab just.
Yeah, I think we can see it behind you. There is like this circle. Yeah.
Yeah.
Yeah, thank you, guys. Maybe one really last question. What is maybe your objective for the next days? What do you think you will be able to come up for the final demo? Can we maybe have a sneak preview what you're doing?
So of course, like the ideas are still like forming and transforming, but I guess everyone would agree like as a cool demo, it would be nice to have nice visualization, maybe even interactive. And like in the weather team, we prepared something. I can share it to you. You're probably able to see it now.
Yes.
Yeah. So this is just, for instance, this is a visualization of the wind speeds over Denmark. So these are measurement points. And one step we had to do is, since these measurement points are not at the points of the turbines, to kind of interpolate the values for the positions where the wind turbines actually are. And you can see here like the strength of the wind, or like the weather conditions all over Denmark for these different positions. And it will be really nice to have this like in time, interactive, maybe even also for the power output, because in the end we are interested in the power output and how well we can predict it. So we can maybe look at both in parallel and see how the time prediction matches up with reality. Yeah.
Cool. Yeah, thank you so much for the nice preview. And thank you for this team update, and talk to you later.
Yeah, thank you very much. Bye-bye.
And thank you. This was our last track. Thank you, guys, for the update. Also, thanks to Alex for the great questions, providing some more insights. Also, not just into how many pants we're wearing, but also actually the data science side of things. So, of course, you know, data cleanup is super important. Actually, people say that 80 to 90% of what people do in data science is data preparation and data cleanup, and also baselining, very important if you want to have any estimate of, you know, what you're actually doing and how you're actually faring. Also really nice to see returning participants from last year. That's always a good sign to have familiar faces here. And also the guy on the bottom right, Dominic, he's actually part of our AI residency program here at the AI Lab, working on neuromorphic hardware, or actually on neuromorphic networks. So check him out, or you know, connect with him, especially on our final event if you want to learn more about our residency program. And with that, moving on, we can wrap up basically. So talking about the live streams one more time, here you get a quick overview. And again, you know, today we didn't show again the videos of the partner companies introducing their tracks. So if you missed out yesterday on the kickoff, you can watch that as a video on demand. If you're Ingenuity, it's right below the stream you're watching right now. And there you can kind of rewatch those videos as well, to get more insights, more understanding on the partner companies and the challenges that they're posing for this. This was our team update. We're going to be doing the same thing again tomorrow. So tune in again at 6:30 Central European Summer Time if you want to know what's been happening in the 24 hours after this one. And again, on Saturday, please tune in for the final pitches and the award ceremony at 4:15. Also, every morning at 9, there's going to be a stretching session with our very own Case. So, you know, if you check out the same link tomorrow at 9 in the morning, you can stretch together with the hacking participants. They're going to be in there, that's for sure. And there's one more thing. We actually just launched our first AI podcast as the AI Lab. It's called Mind Machines and the Gradient Descent, hosted by the great Dr. Uli Waltinger. And there's going to be different speakers every week, people from us hosting as well from the AI Lab. The first episode has just been launched this morning. It's here on Ingenuity as well. You can also listen to it on, you know, basically anywhere, Spotify, Apple Music, Apple Podcasts, right? So just type in Siemens AI and you will pretty much find it right away. Or just stay here on Ingenuity and listen to it, well, I don't know, maybe right now. It's also below this video. And that's it from us. We'll be tuning back in tomorrow, same time, at 7:30. And we're really looking for, no, 6:30. Yeah, 6:30 tomorrow. We're looking forward to seeing you there. And bye-bye. Talk to you tomorrow.